Hi everyone, this is Kalyan Kumar once again, and welcome to Chemistry Universe. This is the last part of the alkene series, and we have titled it Dienes. Now, the reason I'm doing this separately, uh, instead of combining it with the normal alkenes, is because they do behave in a different way. Basically, dienes, as the name implies that a single molecule has two double bonds. But where the double bonds are located changes the behavior of the molecule that is reacting. So let's dive into this. This is going to be a very short video. So let's dive into this and figure out what are dienes and what are the various types of dienes and how do they behave. All right, so here we go. And let's first do a little bit of introduction. Now, dienes are the unsaturated hydrocarbons with two carbon-carbon double bonds in their molecules. These are represented by the general formula CnH2 and minus 2, similar to alkynes, which means that they are functionally isomeric with alkynes. They are functional isomers. However, their properties are quite different from those of alkynes, and depending upon the relative position of the two double bonds, dienes are classified into three types. The first is non-conjugated or isolated dienes. Now, these are the dienes which have two double bonds, but they're so distant from each other that they don't interact with each other, which implies they behave as independent alkenes. And their reaction will be very similar to that of normal alkenes. So, in an isolated diene, the two double bonds are separated by more than one single bond that will help them not interact with each other. So, can you see that in this case, there are two double bonds which are in between, there are two single bonds in between the two double bonds. And if you look at this, again, there are three single bonds. Therefore, they are completely isolated. They behave just like normal alkenes. The next, as we expect, is the conjugated diene. And in a conjugated diene, the two double bonds are separated by one single bond that helps them resonate with each other. So, as you can see this, there will be resonance in this case, and the resonance will change their behavior. And the third type is called the cumulated diene. Cumulated dienes are the ones which are called allenes, and they are not separated by any bond. They are adjacent to each other, something like this. Now, in this lesson, we will be only focusing our attention on the conjugated diene, because conjugated diene is the one that behaves slightly differently than a conventional alkene. Isolated diene behaves just like an alkene. Cumulated diene we don't have to do because they behave very differently and we don't need to do them. And therefore, we'll focus our attention on conjugated diene. So, comparison of stability of conjugated and isolated dienes, it's pretty simple. The relative stabilities of the two types of dienes can also be justified on the basis of resonance. Conjugated dienes are more stable than their isomeric isolated dienes. So let's look at some of the chemical properties. Now, the properties of isolated dienes are similar to those of simple alkenes, which I've said, but those of conjugated dienes are somewhat modified because of delocalization of the pi electron. It's not an electron, it's pi electron. However, they also participate in the addition reactions. The important chemical characteristics of conjugated dienes are briefly discussed. So, conjugated or 1,3 dienes take part in the addition reactions, which can proceed by electrophilic as well as free radical mechanism, depending upon the nature of the attacking reagent and the reaction conditions. So, we know that alkenes show electrophilic reactions, they even show free radical reactions, and therefore, so would the conjugated dienes. And the only difference being that they are in resonance, so that might sort of affect the outcome of those reactions. So, addition of halogen. Now, if 1 mole of halogen attacks per mole of the diene, two types of addition products are formed, and these are 1,2 and 1,4 products. For example, I have a conjugated diene. Now, if I do the reaction of addition of Br2 at low temperature, that is close to -15, I get a 1,2 product as expected, just exactly on that double bond. Remember, I'm adding one equivalent of Br2 per equivalent of the reactant. That's why it's not attacking both the double bonds. Whereas, If you go for a higher temperature, you get this 1,4, a 1,4 product. So let's see how we can get both these products. What is the mechanism? So the mechanism of 1,2 addition is pretty simple. It is just like the normal polarization of Br2 and Br plus attacks, and it forms a 3-membered ring, and SN2 with SN1 character, and you get a 1,2 product. But this is going to be interesting, 1,4. You have this and you have a Br plus. This attacks and this pi bond jumps here. Because remember, as this moves, this becomes plus, and resonance would make this move here, and this will end up becoming plus. So what will happen is the C minus attacks the Br, the lone pair of Br attacks this carbon, and you end up getting a 5-membered ring. And the middle bond becomes double. And then the Br minus comes and attacks one of the carbon atoms. And if the two carbon atoms look different, then it will be again SN2 with SN1 character. It attacks this breaks, and you get the 1,4 product. And to finish it off, we have test for alkenes. How do we test alkenes? Well, alkenes decolorize the pink color of cold KM4 solution, that is base reagent. We've already discussed that. And alkenes decolorize the brown color of aqueous bromine solution or bromine in CCl4. And remember that these two reactions are similar to alkynes also. Alkynes will also give this reaction. There is no way you can separate, you can distinguish between a normal alkyne and an alkene. Terminal alkyne you can, but a non-terminal alkyne with an alkene is not easy to test. You'll have to do ozonolysis or do some oxidation reaction and see what products are formed, and based on that one would be able to figure out whether it is an alkyne or an alkene. So that finishes off alkenes completely. That is the last part. As I said, it's going to be pretty short. So with that, this is Kalyan signing off. Have a wonderful and great day. Stay healthy. Make notes while watching videos. Any academic video, make notes. And thank you for watching this.